this video, we're going to be talking about how to rationalize the denominator. What we need to know is that square roots are not rational numbers, so when we say rationalize something, we mean get rid of the square roots. And so when we say rationalize the denominator, we mean get the square roots out of the denominator. So the first problem we're going to be dealing with is 4 divided by the square root of 7. We've been asked to rationalize the denominator, so we need to get the square root out of the denominator. Well, the way that we're going to do that is by multiplying the denominator by itself. Because if I say square root of 7 times square root of 7, I know when I multiply those two things together that I'll just get 7 itself. And we can prove it to ourselves using this theorem here, which tells us that if we have two square roots multiplied together like this, square root of a times square root of b, that we can take the numbers underneath them, multiply them together, put them underneath one square root sign. So when I say square root of 7 times square root of 7, I know that that's going to be equal to the square root of 7 times 7, or 49, and I know that the square root of 49 is 7. Going back to what we were doing here, we know we need to multiply the denominator by itself, square root of 7. We can't just multiply the denominator by the square root of 7. If we do that, we also have to multiply the numerator by the square root of 7, because if we just did the denominator, that would change the value of the fraction. When we multiply by square root of 7 over square root of 7, this fraction here reduces to 1, right? Anything over itself is equal to 1. So that's like multiplying the original fraction by 1, which we know doesn't change the identity of the original fraction. So we have to multiply both the numerator and the denominator by the same thing, and that's always going to be true. When we do that, we're going to get 4 square root of 7 in the numerator. In the denominator, we'll get square root of 49. Then we know that the square root of 49 is equal to 7, so our final answer becomes 4 square root of 7 over 7. What about this example here? We have 2 over 3 times the square root of. Well, based on the previous example, what you might think to do is multiply both the numerator and the denominator by the square root of 12. That would be perfectly correct, and we could do that, but it might be faster if we try to simplify this square root before we do that. Notice that we have the square root of 12, and we can divide 12 into 4 times 3, right? 4 times 3 is 12. So this is really 2 over 3 times the square root of 4 times 3. And because we have 4 and 3 multiplied together underneath one square root sign, this theorem up here tells us that we can break them into their own square roots. So this becomes 2 over 3 times the square root of 4 times the square root of 3. We still haven't changed our fraction at all, we're just rewriting it in different ways. Now we know that the square root of 4 is 2, so this is going to become 2 times 3, or 6. So what we'll get then is 2 over 6 square root of 3. And now we can simplify 2 over 6 by dividing both of these by 2. 2 divided by 2 is 1. 6 divided by 2 is 3, so we get 1 over 3 square root of 3. Now, to get the square root out of the denominator, we just multiply both the numerator and the denominator by square root of 3 in order to not change the identity of the original fraction. When we multiply, we'll get 1 times square root of 3, which is square root of 3. In the denominator, we'll get 3 times the square root of 3 times the square root of 3, which is the square root of 3 times 3. This is going to be equal to root 3 over 3 times the square root of 9, and we know that the square root of 9 is 3, so we'll get 3 times 3, or 9, and our final answer is square root of 3 over 9. Let's do 2 more examples here. In this example, we have the square root of 3 over 7. So in our first 2 examples, we just had a square root in the denominator. Now we're taking the square root of the entire fraction. This is where the quotient theorem comes in, and this is the quotient theorem up here. What it tells us is that if we're taking the square root of a fraction, we can take the square root of the numerator and denominator individually. So we can rewrite this as the square root of 3 over the square root of 7. In other words, we can apply the square root to the numerator and denominator individually instead of the fraction as a whole. And now this problem becomes more like our first 2 examples. We have square root of 7 in the denominator, so in order to get the square root out of the denominator, we need to multiply by the square root of 7 over the square root of 7. Then when we simplify here, in the numerator, we'll get square root of 3 times square root of 7. Well, this theorem here tells us that when we multiply 2 square roots together, we can combine them into one square root by multiplying whatever's inside together. So 3 times 7 is 21, so that turns into the square root of 21. In the denominator, we have the square root of 7 times the square root of 7, which we know is the square root of 49 when we do 7 times 7. Now we know that the square root of 49 is 7, right? 49 is a perfect square. So we end up with the square root of 21 over 7. And there are no perfect squares that are factors of 21, so we can't simplify square root of 21 at all, and that'll be our final answer. Last example here, we have the square root of 2/5 plus the square root of 5/2. We're going to change this into the square root of 2 over the square root of 5 plus the square root of 5 over the square root of 2, applying the quotient theorem. Then we're going to multiply by the square roots in the denominator. So we're going to multiply this by root 5 over root 5. We're going to multiply this one by root 2 over root 2. And when we simplify here this first fraction, the square root of 2 times the square root of 5 will be the square root of 10. In the denominator, the square root of 5 times the square root of 5 will be the square root of 25, which we know is just 5. Then we're going to add that to root 5 times root 2 is root 10, and in the denominator, root 2 times root 2 would be the square root of 4, which we know is 2, so we get 2 here. Then it's just all about finding a common denominator, so we're going to multiply this first fraction by 2 over 2. We're going to multiply the second fraction by 5 over 5 to find a common denominator, and that'll simplify to 2 root 10 over 10 plus 5 root 10 over 10. Then when we add these fractions together, we just get 7 square root of 10, all divided by 10. And of course, at this point, just like in all of our other examples, we can say that we've rationalized the denominator because we have removed any square root from the denominator and reduced the fraction as much as possible.